In this video, we will introduce the concept of hydrates, how to name them, and then go through a series of examples of naming ionic compounds. Many ionic compounds will bind strongly with water, incorporating it into its lattice structure. Hydrates are ionic compounds that contain a specific number of water molecules associated with each of the formal units of the ionic compound. These generally come in whole number ratios, although it is possible for them to come in things like a half. When we go about naming hydrates, in essence saying how many water molecules are associated with each formal unit of an ionic compound, we do that by adding a prefix to the word hydrate. The prefix is used to indicate the number of waters of hydration, or more simply, the number of water molecules that are associated with each formula unit of the ionic compound. If there is 1/2 of a water molecule per formula unit, or you could think about this as 1 water per 2 formula units, we use the term hemi. Hemi is used to mean 1/2. For 1 water per formula unit, it's mono. For 2, that's di. 3 is tri. 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, and 8 is octa. So what you will do is you'll take the standard name for the ionic compound and add on, after you've indicated the anion, the term with a prefix followed by the word hydrate. So for example, we could have CaSO4, which is calcium sulfate. The dot is used to indicate that what follows it is tightly associated with the ionic compound. So this is how we indicate that something is hydrated, with a dot followed by our numerical value for how many waters, followed by the chemical formula for water. So this would be calcium, Ca, sulfate, SO4, dot, 1/2, so that's hemi, and then water gives us hydrate. So we would call this CaSO4 dot 1/2 H2O, calcium sulfate hemihydrate. We could also look at a barium chloride example. Ba is barium, Cl is chloride. There's 2 to balance out the charge on the barium, and then dot 6 H2O. So the 6 here, we would get a hexa. So this would be barium chloride hexahydrate. We could also look at ionic compounds where the cation can have multiple different charges on it, such as copper. The naming goes just the same way as the other ones. We got copper, we got a sulfate, dot 5, so penta, water is the hydrate, so we would call this copper 2, and the reason that it's a 2 is because the sulfate polyatomic ions will commonly have a -2 charge. So to balance that out, because it's a 1 sulfate to 1 copper, the copper has to have a +2 charge, so this would be copper 2 sulfate pentahydrate. Let's now go through and name a bunch of ionic compounds. So our calcium would be, the ion would be Ca2+, and we know that because it is in the second column of the periodic table. So it is in the alkali earths, so we'll have a +2. The fluorine is in the next to the last column, the halide column, and so it will be minus. We got 2 of these, so the charges balance out. So our name is calcium, right? We name our anion first, followed by the cation. So this would be F is fluorine, but because it is by itself, we get rid of the INE and we replace it with IDE. So that would be O-R-I-D-E, calcium fluoride. Okay, sodium hydroxide, we're working with a sodium, so that is an Na. It is in the first column, so that's a plus. And then hydroxide, if you look back on your previous lecture notes, for a hydroxide is OH-, it's the polyatomic ion. When we are coming up with the formula, we need to add things together to come up with an overall neutral charge, unless otherwise stated. So because there is no indication of a charge in the name, or it is not stated as such, we need to have the charges balance out. So when we add the charge on the sodium, and the charge on the hydroxide, we need to come up with a 0. Because it's a +1 charge on the sodium and a -1 charge on the hydroxide, our formula units would be NaOH. That way they balance out charge-wise. Our next one, the K, is potassium. K is in the first column of the periodic table, so we'll get a +1. Oxygen is O2-. So the name on this would be potassium. And then our O is oxygen. We drop the ending and replace it with "ide." So this would be potassium oxide. Sodium bicarbonate. Sodium again is Na. The bicarbonate, the polyatomic ion that goes along with that, is HCO3-. So this would be sodium plus. So we need a 1-to-1 ratio in order to balance out the charge. So this would be NaHCO3. That's sodium bicarbonate. The next one we have Na. That's sodium. Sodium again has a +1 charge. The PO4 is phosphate. This is PO4-3-. Our charges balance out because we have 3 sodiums per 1 phosphate. The name would be sodium phosphate. Okay. For the ones that we've done so far, we don't have to specify the charge on the species because they are either in the first or second column, so they will only have 1 charge. Silver is another example of a metal that only has 1 charge. Most of the other metals in the D block, so those surrounding silver as well as the rest of the transition metals, most of them will have multiple different charges that they can take on. Silver is one of the exceptions to this general rule. So silver is Ag, and it will take on a +1 charge. The nitrate is NO3-. When we combine them together, we need a neutral overall charge. So we'll take 1 sodium per nitrate. And so that would be AgNO3 for our formula. Next one is copper. Copper is one of our transition metals that can take on multiple different charges. And so we need to first figure out what the charge on the copper is going to be. So we have Cu to some charge that we got to work out. And the hydroxide, our hydroxide ion is -1. Because there's only one of these, only one of the hydroxides, we can tell that because there's no parenthesis around it and no subscript. Because it's a 1-to-1 ratio of the hydroxide and the copper, in order to balance out the charge, because there is no charge written here, they need to balance out, and so the copper will take on a +1 charge. So the name would be copper 1 hydroxide. Okay, our next one is iron 2 sulfate. So that means that our iron is a 2+ charge. Sulfate is SO4 2-, and so we'll end up with a 1-to-1 ratio of our irons to our sulfates in order to balance out the positive and negative charge to come up with an overall neutral charge. So this would be FeSO4 would be our iron 2 sulfate. The next one, Sn, is tin. This is a metal that can have multiple different charges, so we'll need to figure out what the charge on it currently is. Our chlorine, or our chloride, is going to have a -1 charge, and that's because it is a halide and all by itself. So we have 4 sets of minus charges. We need to balance that out with whatever charge is on the tin. So that would be a 4+ for our charge. So the name will be tin 4 chloride. Last one, iridium 3-bromide tetrahydrate. So in this case, we have a hydrate that we got to worry about. So iridium is IR. We know the charge on it. It's a 3. Bromide is Br minus. And the last part is our hydrate is tetra, so there's 5 waters. Okay, so our chemical formula would be IR Br. We need 3 of the bromines to balance out the charge on the iridium. So this would be 3, and then dot 5H2O. This iridium here is not part of the formula. Okay, let's look at even more examples. So here we have a calcium. This would be a Ca2+. It is in the second column of the periodic table. Because it's in the second column, it can only be a 2+. Then we have the hydroxide, OH-. We have 2 of those to balance out the charge. Because the calcium can only be a +2 because it is in the second column of the periodic table, this would be calcium. And because it is in the second column, we don't have to specify the charge on it. So this would just be calcium hydroxide. Next one, sodium sulfate. We have our sodium, Na+, and our sulfate, SO4 2-. In order to balance out the charge, we're going to need 2 sodiums for every sulfate, and so this would be Na2SO4. Next one, K and I. The K is a +1 because it is in the first column of the periodic table. The I is a -1 because it is a halide all by itself. So the K is potassium. And the I would be iodine because it's by itself. We would take the ene, the INE at the end of the iodine, and get rid of the INE and replace it with ide. So this would be iodide. Next one, calcium bicarbonate. Calcium is a +2, and the bicarbonate is HCO3-. To balance out the charge, we will need 2 sets of bicarbonates for every 1 calcium. So this would be Ca, open parenthesis, we're going to take the whole polyatomic ion, HCO3, 2. And again, that is separate. Okay, next one, Li2O. Li is a +1, that's lithium. Because it's in the first column, it can only be +1, so we don't have to specify the charge on it. We have an oxygen, which will be a 2-. Because it is by itself, we will take the egen part and replace it with ide. So this would be lithium. And then oxide. Okay, we again have silver. Silver again is one of our transition metals that can only take on 1 charge. So it will be Ag, the charge on it is a +1. Hydroxide is OH-, and so silver hydroxide would be AgOH. The next one, Pd, is palladium. This is a metal that can take on multiple different charges. Then we have our oxygen, which will be a 2- because it is by itself. We have 2 sets of these, and because it's by itself, we will be using the term oxide. We get rid of the egen, replace it with IDE, so this would be oxide. There are 2 sets of -2, so for the palladium, to balance that out, it will have to have a +4 charge, so 4+, and so the name would be palladium. So the name will be palladium 4 oxide. Okay, next one, vanadium. Vanadium, we know the charge on it. It's a 4 because that's what the name tells us. So this is 4 plus. Chloride. Chlorides are all -1. These are halides, and so they'll take on a -1 charge. So vanadium 4 chloride would be VCl4 for vanadium 4 chloride. Last one, we're working again with a hydrate. There's 7 here. 7 is hepta. Okay, CO is cobalt. So we have CO for cobalt. We don't know the charge yet, so we'll have to work that out. Cobalt can have multiple different charges. We have sulfate. Sulfate ion it's a polyatomic ion that will take on a -2 charge. In order to balance out the charges, the cobalt has to be a 2 plus. So this would be cobalt 2, because that's the charge on the cobalt, sulfate hepta hydrate.